So we'll start now. Just let's people enter. So, good morning, good afternoon to all of you. Welcome to this panel discussions in the frame of the ITA Awards 2021. Today panel discussion will be with a finalist of two categories, Beyond Engineering, Making Underground Works Projects Even Better, and Innovative and Contributing to the Underground Space. So we have two finalists in each category. We will have the four presentations from them at the beginning, and then we will have discussion among us with, of course, attendees. If they have questions, they can ask through the chat. With me to moderate this panel discussions, I have the pleasure to have Hamdi Aydin from ITA Executive Council member from Turkey. And welcome to all of you. And we will start with a presentation from Xiaohui in the category Beyond Engineering. And the title of the presentation is Shield Tunneling Spoil a Waste? Novel Solutions Say No. Just to remind everybody that all the pre-recorded presentations are available in the platform in the recorded sessions rooms for those who have not seen them. Of course, this panel discussion will afterwards be available in the recorded session rooms. So, Xiaohui, the floor is yours.
Yes. Yes. Okay. All right. So good morning and good afternoon, good evening, panelists, friends from all around the world. And thank you for giving us this opportunity for presenting our work. This presentation introduces a novel solution to the disposal of shield spoil in the construction of Shenzhen Metro Line 14, and is presented by me, Xiaohui Sun from Shenzhen University. And the stakeholders of this work include Shenzhen Metro Group, Shenzhen University, China Railway Southern Invest Group, and the other stakeholders as listed below. This is the outline of this presentation. So first, I'm going to describe the Shenzhen Metro Line 14 a little bit. The metro system has become an inevitable choice for megacities like Shenzhen because its huge transportation capacity and the advantage of not occupying surface space. So in recent years, more than 100 shield machines are employed annually in Shenzhen. Among the metro lines under construction, Shenzhen Metro Line 14, with a total length of 50 kilometers, is a benchmark project for green and low carbon construction in Shenzhen. In total, 49 shield machines have been used in the construction of the 88 kilometers tunnel. New technologies has been put into use for green construction. Of course, shield spoil was processed by a novel treatment system, realizing volume reduction and resource utilization. And I'm going to show you the challenges from the shield spoil. So what is shield spoil? In shield tunneling, soil is cut and stirred by shield machine, and by adding foam agent and water, turn into shield spoil with very high moisture content and poor properties. The total amount of shield spoil generated in the construction of Metro Line 14 is estimated as 5 million cubic meters. In the past, shield spoil was transported by special vehicles for dumping. This traditional way not only occupies land resources, but also causes many problems, such as high cost, landslide risks, traffic jams, etc. Moreover, there's no more land in Shenzhen for dumping this shear spoil. So on the other hand, shear spoil is mainly composed of gravel, sand, clay, and water, which are all valuable resources in engineering, and obviously, dumping is a waste of natural resource. But however, there are several major challenges in the resource utilization of shear spoil. First, the equipment needs to be adaptable to different types of shear spoil that come from different strata. And second, the equipment needs to be highly integrated so that it can fit into very narrow space in this mega city. And third, the equipment needs to be intelligent and advanced. The traditional control method requires a lot of manpower. It's not very efficient. Therefore, we come up with a novel solution. An intelligent and modular system was developed and employed to overcome these challenges. This is a view of our system. This system consists of 4 major modules, including vibration sieve module, sand washing module, flocculation module, and the field press module, and an intelligent control system. As you can see, this 4 and Y intelligent system. In the equipment, the vibratory sieve module separates aggregates with a diameter larger than 2 millimeters from the shear spoil. And as you can see, the frequency of their vibration sieve and the pressure of the water flusher can be easily adjusted by the intelligent control system to ensure the capability of the equipment in treating different types of shear spoils. The sand washing module recycles sand with a diameter ranging from 0.075 to 2 millimeters, and the flow rate of the hydrocyclone and the rotational speed of the sand washing system can also be adjusted by the intelligent control system. And the special design flocculation module concentrates the slurry from the previous steps. And the field press module dewaters the slurry to a condition with the moisture content less than 30% to clayey residue. And here I'm going to show you our non-engineering initiatives. In the treatment flow, 4 types of materials, including coarse aggregate, fine aggregate, actually sand, and clay residue, and water, and recycled separately as products from the shear spoil. And the technical route for the utilization of the 4 types of the products has been well designed. Here I'm showing you their technical route. And basically their recycled coarse and fine aggregate can be used for making concrete, mortar, and the backfill or grout on-site or off-site. The clay residue is aggregate-free and potentially quantified for making different types of building materials, such as blocks, bricks, and so on. The recycled water can be collected and used for site cleaning, vehicle cleaning, and all other gardening purposes. And in the last 2 years, the application of this solution has been widely extended in more than 30 construction sites across Shenzhen. Here show you the map, and the points shows the site we use for treatment of the shear spoil. And this slide shows you several treatment sites of the shear spoil along Shenzhen metro lines under construction. Additionally, this solution has also been used in other types of tunnels, such as road tunnels and utility tunnels in the city. And a group of supporting technologies and guidelines for the smooth operation of the equipment have been developed. This effort would lay a very sound foundation for the rise of the new industry related to the treatment of shear spoil. And fifth, why should we be selected as an award? First, this solution has delivered an efficient and sustainable and low carbon way of disposal of shear spoil. The extraction of recycled aggregate from the shear spoil significantly reduces the need of natural aggregate in the construction. It also lowers the usage of traditional special vehicles, which substantially contributes to the reduction of energy consumption and carbon emission in the construction process of tunnels. This solution has contributed to 54,000 tons of construction emission, carbon emission reduction and saved 1.93 square kilometers of land. The traditional way of disposing shear spoil has been changed profoundly in Shenzhen. Nearly 11 million cubic meters shear spoil has been treated across the city. And it also reduced half of the dumping volume and obtaining 4.6 million cubic meters recycled aggregate and sand. And the implementation of this solution also contributes to a total water conservation of 1.16 million tons. So overall, the solution has delivered economic benefits from multiple aspects, worth around 170 million euros. So the outcome delivered by this solution has been welcomed by the clients and communities. The chance of delay in construction schedule related to the shipping of shear spoil, which is very common before applying this solution, has been eliminated. And the project was completed on schedule. And also, less using special vehicles also benefit the communities surrounding metro construction site because of lower traffic pressure, reduced traffic noise, and higher air qualities. So we reduce a very good neighborhood environment. And in the construction of Shenzhen Metro Line 14, the application of this solution and other new technologies has reduced the exposure of workers to risks. For instance, innovative belt conveyor system, prefabricated components, and intelligent control system, and VR training system, and face recognition security system. And due to all these implementation of all these technologies regarding safety improvement, the lost time injury frequency rate remained 0 during the whole duration of the construction. And thank you for your attention. Here is all my presentation. Thank you.
Thank you very much, Jiao Wei,
for
this very interesting presentation. We will come to questions afterwards and to the development of this, how it can be done. Now let's go to the second presentation in this category by Ye Yang on the Shui-Shan Tunnel project of Huaxia Dao Highway. I don't know if I pronounce it properly, but I tried to do my best.
Can you hear me, ladies and gentlemen?
Yes.
Let's do the. Can you see my PPT?
Yep.
The project located on the hinterland of the Qinghai-Tibet Plateau. It crosses natural reserves and the permafrost zones. The length of the tunnel, the left line is 4,570 meters, and the right line is 4,495 meters. The Shui-Shan #1 tunnel crosses a mountain range with an altitude of 4,860 meters. This is some figures of the tunnel. The construction clearance, the width is about 10.25 meters. The height is 5 meters. The emergency parking zone width is 13 meters and height is 5 meters. Shenzhen #1 tunnel is a tunnel in the high altitude, extreme cold area. For tunnels in this area, the waterproof is the fundamental goal of what we have achieved, and the drainage and the thermal insulations are the key points. The entrance section of Shenzhen #1 tunnel is located in the permafrost area of moraine. The permafrost shall be protected during the construction time and after the completion of the project. The annual average temperature in that area is below -4 degrees Celsius, and the extreme minimum temperature is -48 degrees Celsius, which is the area is very distressed. The seismic activity in the area is relatively frequent, and the earthquakes has occurred many times near the tunnel site. According to the new Austrian tunneling method, the initial support structure of the tunnel is usually supported by anchor board, a reinforcement mesh, and shotcrete. However, the primary task of building a tunnel in the permafrost layer of the moraine is to protect the frozen soil. The setting of system anchor boards will damage the frozen soil, induce the deep thawing circle, cause thawing settlement of the frozen soil. It is not conducive to the stability of surrounding rock, and therefore the system anchor boards are cancelled in the design to strengthen support. In order to prevent the thawing settlement and frost heave of permafrost from affecting the safety of the tertiary lining structure, the tertiary lining structure shall be constructed after the secondary lining has completed at least one winter period. The new lining structure design we have invented is the initial support without the system anchor rod plus the secondary lining, and with the geotextile and waterproof board insulation layer, and then we plus the tertiary lining without the insulation layer and the geotextile. The waterproof and drainage design. The water must be controlled before freezing. The geotextile and the EVA waterproof board are used in the design. All construction joints and settlement joints shall be provided with embedded rubber water stops. High efficiency composite waterproof agent and additives shall be added to the lining concrete to improve the self-waterproof grade of the structure. A 500 circular drainage pipe and deep buried central ditch and the new cold proof water release tunnel are formed up to ensure the fish water of surrounding rock can be discharged smoothly into the tunnel. Combined with the topography of the tunnel entrance within 500 meters of the permafrost entrance section of the moraine, the cold-proof drainage tunnel is set below the freezing depth line between the left and right tunnels, connected with the transverse drainage tunnel and the vertical drainage pipe to form a comprehensive drainage system. After 3 years operation, the cold-proof drainage tunnel has strong comprehensive drainage capacity. The highway tunnel design standard specifies that the setting spacing of pedestrian cross passage should be 250 meters, not more than 350 meters. In case of fire in ultra high altitude tunnel, the personnel with the altitude reaction, if you feel nauseous or headache in the tunnel, shall be transferred to the adjacent tunnel through the nearest cross passage. Therefore, the reasonable cross passage spacing is the most effective measure to strive for escape time. The fire module adopts a rapid development fire module. Detection points are arranged every 25 meters in the whole length of the tunnel to monitor the parameters such as the temperature and visibility in the tunnel. The tunnel adopts automatic stepless diamond control technology to achieve on-demand lighting according to the time, speed, traffic volume, and other informations, so as to save lighting power under the condition of driving safety. Improve the installation and capacity reduction technology of tunnel electrical switchgear and transformer other equipments. The heat preservation control technology is used in the tunnel, and we use a heating device in the tunnel portal, and the spacing is controlled at 6 meters, which can ensure the shared temperature reach to 5 degrees Celsius required by the construction. If the temperature is too low, the concrete will be peeling off from the shed, and that's why we make the temperature to reach 5 degrees Celsius. No safety accidents occurred in the whole construction process of Shenzhen #1 tunnel, and 0 casualties were achieved in the construction of super long tunnel in ultra high altitude and extreme cold area. It is an important part of the planned National Western Regional Economic Corridor. It has very important practical and historical of significance for the promoting the economy development of Qinghai province, improving the regional traffic conditions. The driving time was shortened by nearly 5 hours. While the entry should be selected for an award after many scheme demonstration and the technical innovation, many technical problems of tunnel construction is marine permafrost, ultra high altitude and the cold area have been successfully solved, which provides a good reference for similar project in the future. And the new lining structure of canceling the primary shockwave support of system anchor board plus the primary framework lining, and then the secondary lining and the tertiary lining is designed for permafrost surrounding rock, which can make the stability of the rock more stable. And the new cold-proof drainage tunnel suitable for the tunnels in the permafrost area is invented. Here are some rewards and the prize of provincial and ministerial excellent design award. In September and October 2016, CCTV's news broadcast and news studio reported the Shenzhen #1 tunnel was Thank you for listening.
Thank you very much, Yang, for this
Thank you.
interesting project. I do think that workers that had to build this tunnel was not an easy task in this cold environment and high altitude. So it's really impressive of what has been done there. Thanks a lot for this presentation.
Thank you very much.
Now we go to the 2 presentations in the other category of innovative and contributing to underground space. And we'll start with Li Ye. Please, can you Yang, can you stop sharing so we can go to the next?
Yeah, hang on a second. I will do the just. I'll. Yep.
Sorry.
Yep.
Sorry, I made because I don't see any longer what I should.
Okay.
Yes. Can you just add it as a full screen?
Yeah, of course.
Yeah. Let's go.
Can I start? Yeah, okay. Hi, everyone. We are representing the China Railway Design Corporation today to make a presentation of Fuxing Underground Depot of Shenzhen Urban Railway Transit Line number 14, which is actually from the same line of which Mr. Ye Yang shared with everybody else. And my presentation includes 3 parts. Number 1 is the project profile. Basically, Mr. Yang has, Mr. Xiaohui has already shared some of the information with you, which saves us some time. Okay. Part number 2 is about the challenge and the countermeasures of our project. Number 3 is the conclusion. Let's go to number 1, the company, the project profile. Shenzhen Metro number 14, which Mr. Xiaohui has already shared the information with you, is a north to south traffic corridor for the eastern south Shenzhen, and connecting the eastern Shenzhen to the central area, which is the most economic developed area of the Shenzhen city, is also part of the Move East strategy of Shenzhen, and also shares part of the Parallel River Integrated Economic Zone to speed up the development of this integrated zone. Our project is located here in the south part of the whole line, which is the depot, underground depot of this line. The location is for the interchange of this metro line 14 and 11. It's under the central park of Shenzhen, which is a very important location in Shenzhen. The quantity of this work is a pitch of with width of 173 meters, length almost 1,000 meters, and we have an earthquake of earthwork of 1,540,000 cubic meters, which is quite large. For the supporting system, we used boards, beaten piles, plus a concrete roof slab for support. And the main structure is a box structure by top-down methods, and the typical section with 16 spans by reinforced concrete frame structures. The main shareholders, the client is Shenzhen Metro Group, and we are the designer, China Railway Design Corporation, and the contractor is China Railway Turner Group. We have a supervisor, China Railway Siyuan Engineering Corporation. Challenges, part 2, challenges and countermeasures. We have basically 6 parts of the challenges. Number 1 is as a requirement of the Shenzhen municipality. We need to recover and reuse the existing utility, which is Central Park. It's a very, very important place in Shenzhen. And number 2 is we have a new design system, the non-strut supporting system, which I will show you the photos later. And for the logistic, which is quite a big challenge, we need to dispose 1.54 million cubic meters of the excavated material. For the environment, of course, we are doing the construction activity in a dense area, and the noise control network, dust control, wastewater, construction waste are all in treatment of all of these are in a very high standards, and we are in a very sensitive neighborhood. For the progress, this is the largest, and we are in the largest and most important park of Shenzhen. So the authority gives us only 36 months to complete this program, this project. The duration is very tight. And for the safety, we are located in China's most developed economic zone and with the most strict safety standard and requirement. And for this project, there's a lot of challenges for the risk control. And as you know, we also have the challenge from COVID-19, which we have the commitment from our top management. We need to have 0 affected case and 0 suspected case as the target. Challenge number 1, for the recovery of the existing utility. So here you can see the photo of the existing park. We have to demolish all of this park to build a depot underground, and then to recover this utility, which is big work, okay? And we did have a beautiful design. Number 2, for the supporting system. For the traditional supporting system, we are using this the ball piles or the diagram walls plus the strutting, concrete strutting. But in this project, we have a new design, which we call non-strut support. We use the ball piles as a wall, and then from the surface, we use the roof slab as another support to ensure the stability of this structure. And in the underground works, we have this king post. So in the total of this project, we have non-strut and saved a lot of works. Of course, we have less construction waste. Number 3, reuse of the excavated material. This project, the excavation, we have 15% of the completed and the intermediary weathered sandstones, have 27% of the clay, 32% of sand, and 23% of the pebble soil. So we made the clay into the bricks, which Mr. Xiaohui also shared with you. And for the silty fine sand and other sands, we screened this and made it to shotcrete to reduce this kind of material. For the sandstones, we crushed these stones and put it into the temporary concrete material. And for the pebble soil, we make it into the backfill. So by this way, we saved 70% of the total excavated material. We reduced the disposal of the material from 1.5 million cubic meters to 0.4 cubic meters, which saved us a lot of time and cost. By the way, we also reuse the dismantled concrete. We crush this concrete to the small stones and reuse to make the new concrete for the temporary works. Number 5, construction activity in the dense area. So we have to be very environmentally friendly and also community friendly. We are located in a very busy area of Shenzhen, and here we have very important neighborhoods. The most expensive land and persons are located here. We have to take very good care of them. So we use some new new technologies by the drone to monitor environmental factors, and by this integrated environmental monitoring station to monitor the dust, the PM 2.5, PM 10 level, when the alert level is reached. So we have also a spray system to be automatically started to spray the water, so we can control the dust. Also, we use a big data center to share the real-time information to all the authorized users for this project. And of course, we have applied the new material and new equipment to ensure the environment protection. For example, in this, for the roughening of the concrete joints, we use a new agent to be mixed and sprayed before we cast this concrete. And after the casting of the concrete, we use the jet shooting to clean this roof. Then this clean this surface, and the surface is roughened. By this way, we save a lot of time, and also we reduce the noise. And by this another way is how to cut the concrete by the wire saw. And also we apply this electronic excavator with low noise and low CO2 emission. For the noise control also, we put noise control cabin for each equipment with vibration to reduce the noise. Of course, the beam technology was also applied in this project for the progress control and also the demonstration of the conflicts. And the fight with the COVID-19, we have a vaccination for everybody, free of charge, and nucleic test for every 7 day with every 7 day period, also free of charge. We have the face recognition, the entry control in our site. We disinfect the working area, office area daily. And for entry the sites, we basically, this is widely applied in China. We have this passport, show the green card to pass. Yeah. So as a result, for this project, we have some achievements, recovering and reuse of the existing urban utilities. Have the technology, innovation, environmental, and community-friendly outcome. We save the cost. We reach the targets of 0 affected case and review suspected case for COVID-19. Also, we have the client satisfaction. As a conclusion, why should we be selected for the award? So we have we had and practiced the new concepts. First, the project should go smart. The architectural design and the artist design should be integrated with the engineering design. For this project, this is some demonstration of the further project for the ventilation. We make it a double side. These supporting areas, okay, and this depot was also goes underground, which was quite new innovation, because as the know-how of us, most of the depots are in the surface. Yeah, so we believe that this project is a good practice and a good example for the future projects. And for the execution of these projects, we have the concept of go green. For example, for the excavated materials, we not only save the time, save the cost, and so also we reused this material, which is environmentally friendly, and also we applied the electronic vehicles to replace the traditional vehicles, which consumes petrol, yeah. And go friendly, we applied a lot of new technology to make sure that we are protecting the interests of the neighborhood, the community, the client, and all the shareholders. So this is our presentation. Thank you.
Thank you very much for this interesting presentation and the new aspects of line 14 in Shenzhen. As you know, the ITA World Tunnel Congress in 2024 will be in Shenzhen. So yeah, we are very interested by all you are building there, because that will be sites that we will be able to visit, and I'm sure that there will be other ones when we will be there in 2024. Let's go now to Mats with a presentation of the Lefdal Mine Data Center.
Thank you so much. Can you see my screen now?
Yeah.
Perfect. Yep. So my name is Mats Andersson. I represent Lefdal Mine Data Center, Head of Business Development. We have some Perfect.
Go ahead.
I've been working with Lefdal Mine Data Center for 10 years since the project was started. My background is from the data center industry, but also working with creating infrastructure, setting up green infrastructure for the digital transformation that the world is going through, and all the needs we have for enabling this. Today, I will talk about how we transformed a former olivine mine in the west coast of Norway into a world-leading data center. It is going through the background of the project, how the mine was constructed, and the transformation process we had to go through to enable this data center. Sorry. The stakeholders of our project is very committed owners in Columbia Threadneedle, Green Infrastructure Fund, and Rital, a global data center infrastructure provider. They're heavily committed to enabling green solutions for this digital transformation that we're going through, and saw Norway and Lefdal Mine Data Center as a unique opportunity. When it comes to the mining, Sibelco was owning the mine when the operations was ongoing, and we used them and later Sintef for the project when we started the transformation process. And we have used mainly regional suppliers for the construction of that, but also then global suppliers for the data center operation itself. Today we have large data center clients in our facility, international, mostly then from Germany. And this week we announced a new contract where Daimler, Mercedes, is moving their HPC cluster, a large data center contract, to our facility to go green and to reduce their carbon footprint globally. The background of the project is that Lefdal Mine is one of the largest olivine mines in the world. It was processed from the 70s until 2009, so almost 40 years. And the group of people behind the mining process and a local IT company saw the idea of green mineral out and green IT in. Olivine is a green mineral and green IT is the future. Based on that, investors were brought to the table. We also brought in banks, and we managed to come across to them with the idea of building one of the most green and secure data centers in the world in a former mine. In 2017, the project was commissioned and we opened up, and today we are one of the biggest data centers already in the Nordics, and the ambition is to become the world's largest data center. Obviously, by the time we do that, I'm sure that the data centers in China also are as big, at least, but at least the ambition is there. This is how the mine looks. It's a fairly large construction. Up in the left corner, you have the entrance going into a 2-kilometer long spiral connecting then the different levels. We're going to use level 1 for infrastructure. Level 2, 3, and 4 will be the data center, and level 5 we have as a reserve for future evolution. Currently, we have built data center on level 3, and this is what I will show you today. The mine is some 500 meters wide, long, 350 meters wide, and 150 meters deep. The mine was operated in a room and pillar method, mostly horizontal drilling and little damage to the surrounding rock. During the mining process, we had severe securing by scaling, rock bolting. But one of the first things we had to do, of course, when we went in and want to transform this mine was to upgrade that. The transformation process took about 18 months, and we started by having inspections of geologists from SINTEF in Norway. The most prominent geologists in Norway went through the entire area that we're going to use, giving us a report on what we needed to do to secure it so that we had a fully functional space for both personnel, but also protecting then the data center equipment. One of the first things we had to look into was how to use the cooling system that we intended to use. The mine is located next to a deep fjord, 500-meter deep fjord, and we bring the water down into the mine to heat exchangers. So the infrastructure for this was a key for us to enable the usage of this data hall. Once that was in place, the mine itself is a raw building. Compared to building a data center on top of the ground, you will need to build the building, but the raw building is already in place, which means that we have to spend less materials in building the data center than if we build a traditional data center, which is a huge benefit both on the investment side, but also on the sustainability side. The server parks or the IT infrastructure require a lot of power. We also have identical sometimes the amount of power to cool the IT infrastructure. By using the cold fjord and the cold water as a cooling medium, we are able to only use 5% power on top of the IT power for cooling, meaning it's a highly efficient cooling system. So not only do we run on 100% renewable power, but we also use very little of it, enabling the power to be used elsewhere in the society. Here we see some pictures from the initial build out. In the right, we see that we have the ducts for the cooling system A, B. We did some rock bolting and concrete to secure the areas. The entire data center is built resilience, so it's a redundant system with every single infrastructure being in A and B, so that you can have concurrent maintainable infrastructure, and for us in the data center industry, deliver a highly secure and uptime infrastructure for our customers. The entire design and the entire concept of our data center is modular. We build out infrastructure, we build out caverns, we build out customer deployments in a modular way so that we add capacity as the data center is increasing capacity. We start by level 3, we continue on level 2 and 4. We start by single areas in the mine and develop. The backbone of the infrastructure is built to cater for the entire facility, but the last mile infrastructure is built to cater for the individual modular build out. To be able to use the mine, it was important that we did some small changes on the outside. This is an actual picture from the area where we needed to adapt the entry area so that we could install office space, needed infrastructure, and also for security purposes. Here we see a CAD picture of how it's connected with the entrance on the outside, and level 3 then some on the back of the picture where you have then 5 levels of the mountain hall structure. This is the entrance. We're down at level 3. We are here at the 3rd gate to the facility. So to enter this underground city of data centers, you need to go through 3 gates. We are in close cooperation with the Norwegian security authorities to build one of the leading, most secure data center facilities in Europe. Security is important for these type of customers. We're also having a natural EMP protection for our customers, which is important. So everything is of thermal surveillance, motion detector, emission control system, CCTV, security. We have staff 24/7 protecting these areas. Level 3, from a bird perspective, looks like this. On the left corner, we have the entrance that we just saw. And then you come into a city of data centers. The road in the middle is 330 meters long. And to the left and right, we have 28 chambers, or streets, as we call them, where we have infrastructure and housing solutions. In street number 1, 2, and 3, we have redundant infrastructure. So here's where we have the heat exchanger for the cooling. And we also have mechanical power installations, and we have the network installations where we connect to the world around us. Then we have different data halls and container installations where we bring in then our clients. This area that you see is about 80 megawatt, and in total facility capacity going forward will be up towards 400 megawatt of data center capacity. The largest data center in Europe today is 100 megawatts. The different solutions we use to house our customers is either data halls. These are room-in-room solutions. So you use an infrastructure that you normally use when you build a room inside an existing building. So it's limited materials. We build a space where we then bring in our infrastructure, which is power, network cooling, under our raised floor, where we then equip these areas with data center infrastructure. So data halls is one way of doing it. The other one is containers, 40 feet IT containers. The mine itself has a logistical system which is superb for doing what we are doing. And with the high roof height we have in our areas, we can then stack 3 containers on top of each other. Inside these containers, you have servers and you have clients who is running then high performance computing or data storage. And mostly, as I said, the clients are from Germany. Going quickly to why we should win the award. Obviously, we are a big fan of reusing old mines naturally, since we have gone into this project. This is giving new life to a large area that would have been empty if we didn't do that. Left on Mine Data Center, every year we are contacted by other companies around the world, and we have multiple companies coming to us to look how we have built the data center inside the mountain hall or a mine. This is something that we happily share, our technology, our method, and we know that other companies have done similar in China, Israel, and also Sweden because of our project. So we're very proud of that, reusing an old mine. Secondly, we are generating jobs in an area of Norway where it's limited industrial expansion. So we have created more jobs already than the mining process itself did when it was running. But this is just a start. This is an industrial adventure which will create many times as many jobs as it was previously. We're building an ultra green solution. This is the world's most green data center. And we are moving capacity from countries which is running these large power intensive installations on non-renewable power. And we are then effectually reducing the global CO2 footprint, not only for the customers, but for every one of us. So this is a sustainable solution. And as I said initially, Daimler last week contracted a large contract with us because they want to reduce their CO2 footprint. So this is partially a reason. I think that we have a somewhat crazy idea some 10 years ago. We did manage to get that across to the initial risk takers. And I think we have made way for many other interesting parties who wants to do something similar in the rest of the world. And the journey has just started. So thank you so much. That was it.
Thank you, Matt. So I think we are close to normal time, but we can spend a little bit more to have some exchange between us. Amdi, do you want to start with a question?
Yeah. First of all, I want to thank to all presentators for nice presentations. And we had 3 from China, and then we come back to Europe, to Norway. Actually, 2 presentations are from the Shenzhen Metro Line 14. One is actually the tunneling spoil is always all over the world a problem. If you are in US or in China or in Europe or where you are. And there's also a lot of different solution for that. And what you have done in China is one of this. And my question is, what you have done really impressive. Have you a comparison? Did you compare your systems with the other systems used in other countries? And what is the cost of 1 cubic meter spoils for recycled? And the cost of the systems, I mean, you said it's 1.2 billion euros overall investments, and main structure cost is 780 million euros. What is the cost of this systems that you invest firstly? What is the percentage of this investment to the total investments in this project? If you are muted, yeah.
Hello.
Right.
Should I answer the question right now, or
Yeah.
Yes, please.
Let's go.
Okay. So first of all, the first question we did, because we compare with the system from other countries, and we also define, because we also have equipment from because they are kind of a manufacturer in China, selling the products and the equipment, and but here we just invent our own system, which is more just based on the Shenzhen's geological strata and the local situation. And the difficulty part is in Shenzhen, there are a couple different types of soils, silt spoils, just like this kind of rock or some kind of residue, granite residue that causes different types of equipment requirement. That's why we have to use our own stuff. And also we have compared the different systems, and also our system evolved from the very beginning to the current, we call the third generation, which is much adaptable to our local situation. And this is the first one. And second one, the cost. Actually, just a second, I have we did a calculation before. As I said, it will be just a second. I want to check the cost. For 110, I mean, it's not cubic meters. It's just 110 will be like a 16 RMB for the separation of the, separation of the sand and gravel from the slurry. So this will be
two euros per ton.
Will be like
Yes.
just probably just one. Yeah. And for the further resource utilization, just like making bricks, blocks, that will cost much more, but the benefit will be also have more. So we didn't really focus on that part, but for the separation part, it's just like €1. And the third question is the cost for the whole system. And we have applied, as I demonstrated, we have applied like 13, I think it's 13 site on along the 14, Metro Line 14, and the total is more than 30 in Shenzhen, this kind of system. And as mentioned, this kind of system evolved from the very beginning to the current generation. And for the newest generation equipment, I can recall, it's like around like 4 million RMB for one system, but that will be reused again and again. So we just change some parts, and after this situation has been done, we move to the next step. So this is the third question. And number 4, I just missed the question of number 4 because pretty noise outside when you ask the number 4 question.
And another question is how much gravel, sand, and water can be gained from 1 cubic meter spoil?
Oh, that would be a very good question. It depends on different types of spoil.
Yeah,
and
the average. The average.
Yeah, sure. And as what we conducted, the situation is like we have 30% of gravel, 30% of sand, 35% of sand, and just like and 30% of clay residue. So just around that kind of range, that will be very profitable to the people who want to conduct this kind of work.
Okay.
Yeah.
I have one additional questions to you concerning the space needed in the work site, because sometimes in urban areas the choice of EPB is also coming that the fact if you had a shield tunnel you need to have a separation with bentonite and so on, so lots of things. But in your case you have an EPB, but you have added the separation system, so in terms of space it might be. And the other thing is even when we are using biodegradable products for terrain conditioning, you need sometimes before it dissolves, so you cannot use directly the spoil because it contains, even it's biodegradable, some products that are not the terrain, and at least in Europe they are considered as not being to be used directly as your products.
Yeah, yeah. So should I comment on that?
I don't know. Is the space in terms of work site important, because it is sometimes one of the consideration when you have when you are between here you are adding separation equipments. That means you need more space on your work site.
Yes, that's right. That's what I mentioned. That's the challenge too, because in Shenzhen, it's also very, the construction site is also very narrow, and we have a very risk, requirement for this kind of equipment, and but we based on the capacity. The capacity of treatment of shear spoil, we designed a different kind of system. Like for one, I just make one example. For the situation I showed in the slide, we have just a second. We have 1,600 cubic meters per day capacity. And with like 400 square meters space for the kind of equipment. But if we want to lower the capacity, and we just needed just only like 200 square meters, will be enough. Yeah.
Thank you.
We have a serious equipment.
Yeah, thank you. Yeah. Now, while we are in the line 14, I want to continue to another third presentators, and this is an underground depot you were presenting us, and you said in your presentation half top down. What's the half? What is the another half? Normally we have half top down. What is the another half? Normally we have top down or conventional systems. You said half top down. What is the difference between the half top down and top down? I couldn't get it really. Perhaps I couldn't. I should watch your presentation another time, or I watched it 2 times, but I couldn't get it.
Okay, let me show you my screen. Wait. So can you see my screen?
Yes.
Yeah.
So actually, the half top down means, sorry. In this area, we are cutting excavates these parts, and then cast these slabs, the roof slabs, part by part. So we call this half top down. So because we are not covering the
whole area, because of that you call it. This is top down actually.
It's top down. That progressive top down.
Progressive top down. Yeah, this is the usual.
The new top down.
Yeah, usual top down. Okay. Okay. I thought you use some parts in conventional systems and some in top down. Now it's okay. Okay.
No, the innovation is we use this roof slab as a part of the supporting system.
This is top down. You build first the roof slab, then you go down. Okay. And you said this is normal procedure. You are saying beam-based site construction management information technology that you use. And so what is the utilized beam level here? In beam 1, 2, 3, 4, 5, it goes up. Which level do you use there? Beam level.
Sorry, wait a second.
Okay.
Excuse me, actually, I'm not an expert of BIM, but we did apply the BIM technology. We use this for the progress control and also
just for the construction. Not you didn't consider the time and the budgets, as I understood. Did you take into consideration the budget and the time? Not. No, just the construction. Okay.
Yeah.
Okay. Thank you.
Okay.
Thank you. Yeah. Perhaps you have some question.
I would have a questions to Young on the because it's very impressive because I'm very interesting by your cold drainage tunnel because it's something totally new. That's the first time I'm hearing about it, and because the issue is normally here you are in a zone where it's frozen all the time, but the issue is with building the tunnels and having cars and so on. You need to prevent the heat from the operation of a tunnel to defreeze the terrain. Is it really this the main challenge in your tunnel?
Yep. So because the temperature is like it's very low in that area, very distressed area. The it's about 4,860 meters. You know that Qinghai, Tibet, that area is very cold all the year round. And a new lining system is invented. We use the initial support with all the system anchor rod and the bolts, because if you add the primary bolts, the the frozen soil, you cannot destroy that because it's in the natural reserve. We have to meet the environmental sustainable for the future of our generation. That's why we cannot. If we use the initial the anchor rod, it will like transfer the heat inside the frozen soil. We have to protect the permafrost from the construction site. That's why we can the canceling of the primary anchor bolts. And then we we have three linings: the first lining, a secondary lining, and the tertiary lining. When we finish the secondary lining, and then we have to leave the construction site for at least one winter period, and then we use the third lining, the tertiary lining, and because it's more feasible and more it's very good.
Okay, thanks a lot.
Yep.
Yeah, I have a question to him also, and we have in Turkey a similar tunnel in Turkey we built, and it is almost 15 kilometers long, 15 kilometer long. But before the tunnel there was, and the road was mainly closed in winter period. And here your elevation is much higher than in our case. It's almost 4,500 meters, and
4,860 meters.
Yeah. How do you keep the road open in winter periods? And outside temperature is -20. I say just the average, not the maximum. And the outside is -20 degrees. And when you come inside the tunnel, it's perhaps maximum up to 5 degrees, I guess. And how do you control the traffic there for the accidents and for the temperature to keep the people in traffic control? How is the control system? Do you have a special control system for that? for the tunnel.
Give me a few seconds. I will discuss with my supervisor.
Okay.
All right.
Okay. So in between, I have a question to Mats, because you said that you are using the water of the fjord to cool as well. If it would be also a cavern, but with not this cold water to be used for cooling the system, would it have been possible to have a data center? Because we know we always promote by ITA that building in underground specifically for data center is cost saving and is green. But of course, in your case, you have additional advantage of being close to the fjord and then having this cold water. I suppose you have other data center somewhere else with not this advantage? How is it? Is this advantage very big, and how is it in the other places?
Yeah, for sure. I'll try to be very quick. You're right. It would be more demanding or challenging and cost more expensive to build the air-cooled solution inside the mine. Even at our mine, it would be even more difficult than others because we are in the lower level and we need to transport more. Having said that, it's possible to do that, but it will not be the same cooling efficiency, and it will also be a more expensive investment. So the efficiency of air cooling is about 20%, 25% achievable above the usage, while we're at 5%. So we have an ideal location, and very luckily. And but having said that, we are in favor also of building data centers inside, reusing mines or mountain halls with air cooling because it's possible, and it's a secure environment, and it's really as good as building a normal data center if you can transport the air.
Okay, thanks a lot.
Yeah.
Yeah, I have also to Matt's question. It's really a green project. It's green IT. You said. You said there's a lot of renewable energy. What kind of renewable energy do you use there?
In Norway,
my first question.
Yeah, in Norway is mainly hydropower, and in our vicinity of our facility, it's hydropower. We're building windmill parks as well on the coast of Norway now in a fairly large amount, but currently some 94% in Norway is hydropower.
Hydropower, okay. And you said that there's already more job opportunities from the mining process itself. Could you explain that how many people are working in this IT and what kind of work they are doing? Normally, we know that mining is human-intensive industry, but IT is less human-intensive. I know what I am missing here. Can you tell us about this?
Yes, I can. So during the mining, it was some 45 people involved in the mining process itself. Today, we are already more people working in the mine, even if we're only at 5% of the total volume, meaning that we have additional people coming in vast amounts. People are split into operations and entrepreneur. So we're going to build out this facility for at least 10 years to come. It's so large, so many halls, chambers, levels. So it's a construction to be ended in 10 to 15 years. So that's half of the people currently working, while the other half, which is now the lower level, is in IT operations, working in the environments, building the infrastructure of the racks and supporting, and also replacing, doing super monitoring on the installation itself. It's very demanding actually, because you need to replace equipment along the side. Eventually, we will be some 200 people working on the operation side and between 50 and 80 people on the entrepreneur side.
Okay,
thank you.
Thank you.
Let's go to the answer from Ye Young, and afterwards we need to close this session.
Yep. Yeah. I'll answer the question. The waterproof and drainage design. The water must be controlled before freezing. You know, in the tunnel site, the geotextile and EVA waterproof board and are used in the design as well. All the construction drawings and settlement drawings shall be provided with the embedded rubber water stops. And the main core of the design is the 500 circular drainage pipe and the deep buried central ditch underneath the left and right tunnels, and a cold-proof water release tunnel are formed up to ensure the fish water from the surrounding rock can be discharged smoothly into the drainage system. In some parts of our country, the situation that you mentioned before, we can make the traffic go, and we close the tunnel for well, and other like very important emergency traffic or something, we open that again. I do that rapidly. That's it.
Is there a control room or control building that you are controlling the traffic there? Because it's very abnormal tunnel. Outside temperature and inside temperature, the difference is huge. When one car is coming from inside, going out, and can do some very bad things, and can be happens very bad things. Because of that, I asked the control systems.
I don't know if he knows about this because it's operational, and I'm not sure. But
Okay.
okay. So
okay.
Thank you. Thank you to everybody for this panel discussion. We, of course, tomorrow at 2 p.m. CET, 1 p.m. GMT, there will be the awards ceremony. So we will unveil the winners. You will receive an email. I don't know if Sonia has sent it yet, or will send you a few moments. So we invite you to connect through the platform, and when it comes to the category, you will be invited as panelists, and the winner will be allowed to say some words if he wants to. And so thank you again for this interesting live session presentation, and once again congratulations to all your projects. And we will have another session this afternoon with finalists of a category project of the year between 50 and 500 million euros. So see you next. Bye-bye.
Bye. Thank you. Bye.
Take care.